Our project title is Secure Data Transmission Through Image on Optical Steganography Based on Noise. Abstract. The enhancement of secure transmission through data hiding in images on optical communication has been demonstrated experimentally. The steganography technique is used to hide the information and to communicate a secret data through histogram enhanced image via optical channel. The dispersion effect is deployed in order to improve the security of the stealth data. The dispersion effect at the transmitter and the receiver functions as a key factor for the optical communication. In this proposal, an algorithm called LSB replacement algorithm is used to conceal a large amount of secret data into the pixels of grayscale image. Finally, the enhanced performance through an optical channel will be based on the parameters such as mean square error and peak signal to noise ratio.
Introduction. The word steganography is of Greek origin and means concealed writing. Optical steganography is the practice of concealing a message or information within other text, images or audio through optical channel. Optical steganography aims to transmit stealth data in public fiber optic communication system without being detected. Optical communication. Fiber optics is a medium for carrying information from one point to another in the form of light. Unlike the copper form of transmission, fiber optics is not electrical in nature. A fiber optic system consists of a transmitting device. It converts electrical signal into a light signal, an optical fiber cable that carries the light, and the receiver that accepts a light signal and converts it back into an electrical signal. The complexity of the fiber optic system can range from very simple to expensive. Advantages of optical fiber communication: enormous potential bandwidth, small size and weight, electrical isolation, signal security, low transmission loss, and potential low cost. This is the literature survey. In 2015, logical connective model with LSB algorithm is used, which results in low secure transmission. In 2014 paper, LSB algorithm is employed where noise and dispersion is not compensated. In 2013, homodyne detection is employed. In this, eavesdropping is not completely prevented. In 2013, AES encryption algorithm is employed where the data hiding through cryptography technique is proposed, but it also results in low secure transmission. In 2012 paper, data hiding through cryptography using a LSB algorithm has been proposed. In this paper, the recovery of data is difficult. In our proposed work, we overcome all these drawbacks. Proposed system. The goal of the proposed work is to prevent the eavesdropping and to ensure secure data transmission with the effect of dispersion and optical steganography based on ASC noise. Deployment of dispersion effect is used in order to improve the security of the channel. The dispersion effect due to larger length of the optical channel is reduced by increasing the PSNR, and also if the data rate is increased, the error rate will decrease, and thus the dispersion effect is compensated. This is the block diagram. Here we are considering an 8-bit input image, and the 8-bit input image is in the form of RGB, that is converted into a grayscale image using the pre-processing stage, and the grayscale image has to be enhanced by using histogram equalization technique. This secret data is hidden into the histogram enhanced image through LSB insertion algorithm. The final resulting image we call it as stego image. This stego image is carried through optical communication channel path, and the stego image is extracted by using LSB extraction algorithm, and we finally get image and data separately. Pre-processing. Here the RGB format image is converted into a grayscale image in the pre-processing stage. Using this formula, X is equal to 0.299R plus 0.587G plus 0.114B. R, G and B refers to red, green and blue plane. In histogram equalization technique, the key advantage is that it is a fairly straightforward technique and also an invertible operator. This method seeks to adjust the image to make it easier and also to improve the visual quality for analyzation. LSB embedding. 8-bit grayscale image consists of m cross n pixels and a secret message contains of k bits. The first bit of the message is embedded into LSB pixel of the first pixel. Second bit of the message is embedded into second pixel, and so on. In this way, the data is hidden into the image. Optical communication channel path. We consider the communication channel given by a fiber optical transmission line. We develop a method to calculate the information capacity of a non-linear channel given by the corresponding equation sigma square is equal to n0 divided by 2 integral of minus infinity to plus infinity modulus of h rx of f whole square df. Amplified spontaneous emission ASC noise. The wide spectrum and random phase of ASC noise are the main advantages for hiding these stealth signals. The spectral width of ASC noise is around 10 nanometer, which is about 1.3 terahertz in terms of frequency. In comparison, the standard public channel has a bandwidth of 10 GHz. A wider bandwidth results in larger optical delay with the same amount of dispersion. So, the stealth channel has less tolerance to uncompensated dispersion. Adaptive LSB extraction. In this, the first bit of the message is extracted from the LSB of the first high frequency coefficients and the second from second reverses coefficients and so on. This process is repeated up to all the secret messages are retrieved, and these bits are grouped into 8 bits to form a character values.
The quality measures. The reconstructed image quality is measured in terms of mean square error and peak signal to noise ratio. The performance is evaluated by mean square error and peak signal to noise ratio formula. Mean square error is equals to summation x of I comma j minus y of I comma j the whole square divided by m cross n. Peak signal to noise ratio is equals to 10 log base 10. Peak signal to noise ratio is equals to 10 log 10 256 cross 255 divided by MSK. In our existing method, histogram enhancement technique is not performed for grayscale image, which results in higher error rate. So, mean square error obtained will be increased and peak signal to noise ratio is decreased here. In our proposed work, the grayscale image is histogram enhanced to increase the intensity of the image, which in turn decreases the mean square error and increases the peak signal to noise ratio. This is a comparison between two different images for existing and proposed system. Here the mean square error rate is reduced in proposed method. In existing method it has been increased. In the same way, the peak signal to noise ratio is also decreased in existing method and increased in proposed method. Comparison between existing and proposed method analysis on stego image communicating through optical path. From the obtained curve, the x-axis is in terms of data rate and y-axis in terms of dispersion. The error rate is reduced from 0.000009 to 0.000003. Error rate reduction is 0.000006 picosecond per nanometer. Probability density. The energy distribution of the normal image and the histogram enhanced image is shown. Conclusion. The enhancement of secure data transmission through image based on optical steganography and the effect of dispersion on optical steganography based on AAC noise. Deployment of dispersion effect is used to improve the security of the channel. If the data rate is increased, the error rate will be decreased and thus the dispersion effect is compensated. Eavesdropping is completely prevented by this method. If this project is implemented in hardware, it can be used in military and defense purpose for secure retrieval of important messages. In future work, we can hide the secret data in videos instead of single image. These are the papers we used for our references. Thank you.